Hi, my name is George Woodrow, and my talk at the Wolfram conference is going to be about Eliza's legacy, chatbots. Today's Martin Gardner's birthday. Those of us who are a certain age will remember him from his articles in Scientific American. I saw a quote today that said he made children into mathematicians and mathematicians into children. So I don't think Martin Gardner had an article on Eliza, but he had an article on almost everything else that happened in the 50s and 60s and 70s. So here we go. Okay. Just a little background. Eliza is an early artificial intelligence program developed in the 1960s by Joseph Weizenbaum. I think Weizenbaum, I never heard his name, at MIT, and it emulated a Rogerian psychotherapist. I came across the program in the 1970s when a version in BASIC was published by Creative Computing. I was a researcher at the University of Pennsylvania at that time, and when I wrote the code and showed it to to the graduate students, I was amazed that some of them actually thought there was a person inside. Graduate students are so gullible. Eliza is arguably the first chatbot. Today they're all over the place. I found a website that uses a chatbot to help people beat parking tickets in New York City. And I think a couple other cities here, but I live right near New York, so. Undoubtedly, some of the chat windows that I've been at talking to support, I was actually talking to computer at least some of the time. So I became interested in using a chatbot when I was talking to my local college, my alma mater actually, math department, about using mathematics in the classroom. And I was dissatisfied by the fact that they only wanted me to use things that had like true-false questions and multiple guess questions as a means of assessment. And I said, this is a place that's charging $40,000 a year in tuition. They're more expensive than Princeton. They should be a little more creative than that. My feeling is that the best use of a computer is to help students achieve mastery, and that involves some sort of interaction, and that's when I remembered the Eliza program. I poked around. I found the basic source code. Somebody had put up a command line version in Mathematica in 1992. And the program really doesn't need to be complete. If 80% of the material can be covered by using a computer, then the time the student spends with the teacher will be much more useful. And we can also count on the student or other user to be helpful. I mean, if you're on a website trying to get something out of customer service, you're not going to be off talking nonsense to them. So I had hoped to show you a complete instructional application at the conference. Unfortunately, the R&D phase took way longer than I thought. Okay. Yeah, I think I'm out of phase here. No, I'm not. Here we go. Eliza was originally written as a command line program for what was then an innovative time-sharing computer system. Obviously, an interactive program would not work if you're using punch cards and you had a 24-hour turnaround time. Coincidentally, I learned on a time-sharing system. If I had to use punch cards, I probably wouldn't have learned to program at all. It was easy enough to create the user interface for the conversation. As you can see here, this is just a mock-up. I emulated the Mac OS message application. Pretty much all of them the same. And Stephen, in fact, showed an implementation for the web interface in Mathematica looked pretty much the same. I just didn't put in the little pointy things coming out of the sides of the conversation. The real difficulty is inputting text. And we needed a way to have the input field that essentially worked like the command line interface. It would just sit there, wait for you to type something, and then do some processing once you hit the return or enter key. And there are 3 different options that I tried. I'm only going to show you the one that worked. I was totally stumped. This is a major part of the R&D that took me so long. I just couldn't get the thing to work. I knew about event handler. Kyle Martin in the technology group did some spelunking, and he found something that worked. And here's the basic code, I think. Yeah, this is already implemented. So you just type in your message. You notice that the brackets not executing, and then it just comes back and it just, so that's it. That was the key thing. This is the key, and you could probably use this code in a lot of other situations besides making a chatbot. So here's a working chatbot. This code is available as a package on the Pathable thing, and it's also in a non-package format in this notebook. So you can just type something in, and it's pretty dumb because my simple processor is really, really dumb. Now we get to the working example, and because I'm using the Ethernet for the Wi-Fi for the internet, this should be work. And kind of works. There are a couple of things that I noticed about this. First is that what was really amazing in the 60s and 70s isn't now. The next thing is that everyone expects spell checking, and it did not implement that. But if you did something like typed in it knows that. It's not a perfect implementation, but because it doesn't recognize Klingon. Anything that's not, you can type garbage in, and it still thinks it's, I tried Klingon really, and it still thought it was English. So the code for this is at the end. I used the original paper by Weizenbaum. I'm going to call him that because I'm not sure. It didn't have any code with it, and it wouldn't have done any good anyway because it was an obsolete language on a computer that doesn't exist anymore. But the basic ideas are there. The PDF of that document is also on Pathable. So I looked at all these things here that I included in some form or another, or plan to. Text structure, which Stephen alluded to, is really powerful. It's not ready for prime time. It makes lots of mistakes. We'll talk about that later. Language identify works pretty well, but it's confused by short inputs. Text words is what I'm using here, which is why it needs an internet connection. String split does basically the same thing, but not as well. Text sentences is something that I want to do because now this is everything they're assuming is just one sentence if you get verbose. And associations I looked at and I said, well, I'm running out of time. I don't want to have to learn association, so I use something else instead. I'll try to pump the screen up on this one. This is the structure. Basically what the program does is you get the input, it does some processing, turns everything lowercase, turns everything into a string of words. It looks for keywords. In the first column here are equivalent keywords. This is a weight factor, so it'll look at that first with a higher weight factor. Some pattern matching here, and then some responses. So in this case, if I had brother, it would look for 0 or more words, followed by my with 0 words, 0 or more words, and then brother. The little marker there is for whatever the keyword you found was. Exactly 1 word, and me. And then it formulates one of these 2 things, picking out number 4, 1, 2, 3, 4. So this would say, does your brother really, and whatever word was there, like me. And there are all kinds of things like that. And this is essentially the structure that the original paper had. The basic program was much simpler than that. It just found the keyword and then processed whatever was after the keyword. And it kind of worked, but I didn't really like it. The problem with this is that this list of lists is, breaks easily. It's hard to maintain. So the next stage will be to turn this into an association or even one of these custom entities, something to look into.
Was the original Eliza completely stateless? In other words, every single thing someone typed was only looked at by itself, not anything previous?
Kind of. There was a special case there where we'd look at previous things when it got stuck. But the basic one didn't have that, and I was, the way that they had implemented it would have taken longer to do in Mathematica than I wanted to. But yeah, the next stage here, because the Eliza thing is cute and all that, but it doesn't really meet any educational need. It was an exercise in seeing what do we need. So we need to have some kind of script to follow, something that will parse the script. In a real application, you need to know about the real world. You need a separate model to work on. I mean, the interface we have here is the view, and this part that I wrote here is kind of the controller, and the script is part of the model. But if I wanted to, say, write a program that would help a student with species counterpoint, it would need to know the rules of species counterpoint. It would need to know the state of the exercise as you're going through and various other things. So rather than implement essentially a one-off, I punted. Okay. Well, let me drop out of this because it's not letting me finish. They go to the next, well, let's go to the end and I'll see if we can get there. Okay. I put all the source code at the end and there are comments in there. Let's go back to the previous slide. Okay. The next thing to do is obviously to make something a little bit less primitive in the script. And there are other things, generalize the script for other kinds of interaction. If you had a simple 20 questions type of thing, which would be the chatbot for, how to beat a parking fine, then you need a different kind of script. So I wanted to generalize that so that one style of script would work pretty much for anything if you want. Speaking and interest, listening would be nice. Okay, I'm going to put all this stuff up on the Wolfram community, and there's my email address, because I just saw something really shiny to work on next, and I'm going to be doing that. And obviously, a cloud deployment would be really nice, and if you did that, then you could probably do some kind of data analysis of the responses from the website and make things better. The text structure is something that Stephen Wolfram said last night about his work on, natural language processing. He said, well, if you feed poetry into it, you're going to get garbage. It's not, you can lose the meaning of the thing. And from everything that I've been looking at working on this, the line between what they used to call steno language when I was in college, they probably call it something else now, instruction manuals, that kind of speech. What Wittgenstein, I think it was in Philosophical Investigations, was looking at when he was having people, hand me a brick, hand me this, you quickly get into metaphor right after that. So we're going to need something that's going to handle metaphoric communication. And my feeling is that metaphors all over. I mean, energy, the idea of energy. I mean, we have got formulas for, we got this and that, we got ways of transforming it, but the idea of energy is a metaphor. 3 is a metaphor. 3 sheep, 3 cattle, 3 sticks, that's fine. So one of the difficulties in making a link between the two worlds, I've got 1 foot in each, is to recognize this nature of human language, and I don't think artificial intelligence is going to get too far. And in fact, until we get something that can understand more of the world, we're not going to get anywhere. What Eliza does, and what most of these other things are going to do, is just fake it, or have a very restricted domain. One reason I picked counterpoint as an example, species counterpoint, probably no one has ever taken the counterpoint class here. You started out with first species, you got whole notes against whole notes, and then you go to second species, half notes against whole notes, and you got rules, and you got all this stuff here. And essentially everyone since Mozart learned how to write contrapuntal music in this way. I mean, Bach had the thing, but he already knew how to do this stuff. And one of the challenges was going to be, it's pretty easy for first species because you have very tight constraints on what you can do, and the model the computer has to work on can be very simple. But as you add complexity with the further species, you're going to get to a point where chatbot's not going to be able to help. And I already know that fifth species is out of the question, won't work, because there's just too many things that can go on. And there's a line where you're crossing between doing a simply mechanical exercise and then doing something that requires some thought, some aesthetic sense, and the computer has none. So that's where I'm at. I'm going to continue working on this, but it'll be a back burner project because the new audio stuff is really nice, and I'm going to be working on that. So any questions? Sure. Yeah.